Hey, today we're going to continue with some discussion about structures of molecules, particularly the ones that violate the octet rule. And so today we're going to do chlorine trifluoride. This is a weird compound, I know. It's not one that we see a lot of times. The only time I've really seen it is in the example provided in the chart for the molecule shapes. But since we do need to know about how to construct molecules, doing Lewis structures, formal charges, all that stuff, let's take a look at this guy and see what we can do with him. So, chlorine is 7 valence electrons, and then we have one of them, so 7 times 1 is 7, and then we have 7 valence in the fluorine, times 3 is 21, 21 and 7 is 28. So we have 28 total valence electrons to play with in this structure. Now, this is weird in that they're both halogens, but since the chlorine comes first and we have only one of the chlorine, we make it our central. And if you remember what I've been telling you, fluorine is too small to violate the octet rule. So that's the other thing that we should be thinking about is, hey, this chlorine, it can't violate this chlorine's the only one that can be central because it's big enough to violate the octet rule. So I'm going to put my chlorine down here, and then I'm going to go ahead and attach 3 of the fluorines, okay? And so that's 6, so that's 22 that I've got, okay? And then I'm going to go 2, 4, 6, 2, 4, 6, 2, 4, 6, and all I was doing there is giving the fluorides, or the fluorines, the electrons that they need, okay? So now I've used 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, okay? So I've used 24 total, and I've got 4 left over. So all my fluorines are happy, or fluorides. It doesn't really matter how you call those, because it's just in the naming that it's chlorine trifluoride. But fluorine, fluoride, they're good, and they can't violate the octet rule. They can't take on any more. But I got to put these 4 on here. It would seem like the chlorine would just want bump bump 1, but there's 2 sets, so we have to put the 2 sets on. So that's what we're doing right there. Okay. And then, essentially, this is also the structure of the molecule, okay? This is a T-shape, and let me pull out my molecular models, and I'll show you how that works. You can have a sandwich or something while I'm doing this. So, boom, boom, boom. And that's how it makes a T-shape. And so there's an unshared pair, and so you can see it. There's an unshared pair, and there's an unshared pair. And so that unshared pair is pretty far apart, and it pushes down all the attached fluorines into those 90-degree angles, okay? So when you're drawing it, you just kind of go and 1 forward, and you can see that when you put the T here in the plane of the paper, you got 1 set that's going back, that's that set, and 1 set that's going forward, and that's that set. Now, if you want to just check the formal charges, fluorine is 7, and it has 4 unshared plus 1/2 of 6 is 3. And so 4 plus 3 is 7. 7 minus 7 is 0. And then the fluorine is just normal. It has 7. And it has 6 unshared plus 1/2 of 2 is 1. And that's 0. So the chlorine, it has 7 valence, 4 unshared, boom, boom. And then 1/2 of 6 is 3. 4 plus 3 is 7. 7 minus 7 is 0. Sucker works, that's all we can say. Okay, it's a good formal charge. So it's T-shaped, got the 9120 we'd expect. That's all I got for you. Have a good day.